lead here. So let me start with the first slide. Good morning, everybody. So today the topic of the fire alarm detection will be focused on the correctional facilities, as been explained by Wai Min just a moment ago. This correctional facility terms is a general term for prison, jails, or like detention center or lockup area in the police station. So it is a general term, not only focused on the prisons or jail. So we also have a special center for the underage criminal, like those below 18 or 21 years old. So there are many types of facility available depending on the types of application. So as we all know that in this kind of facility, usually the security is a very stringent, and they have a lot of access measure to stop the occupant inside the area from moving too freely, I can say. So they are limited within the compound. Okay. Then the purpose of this correctional facility is to securely keep the inmates behind the bar, and also we need to ensure the occupant safety is a critical in the design consideration of fire alarm system as well. So on the right, you can see some of the photos of the Solothurn Correctional Facility in Switzerland. So for the life safety standard, we are able to refer to the NFPA 101. This is the fire alarm system guideline for detention and correctional occupancy. So we shall follow this guideline for the installation of this fire alarm system and the notification system as well. So most of the time we refer to the National Fire Protection Policy from the FBP, Federal Bureau of Prisons, and we also refer to the American Correctional Association Fire Protection Standard. These are the major standard that is available. So now we look at the risk, the life safety, and also the fire prevention in the correctional facility. According to NFPA, the NFIRS, the Incident Reporting System, and also survey from NFPA, there are 62% of the prison fire occur in the cell block. What are the cell block? Cell block are the room dedicated for each and every occupants in the prison or facility. So every year there are average of 400 fire reported from the year 2010 to 14 in USA. There are 400 every year, which means there are more than one fire for a day. Of course, the leading cause of fires are usually arson, the deliberate cause causing some fire outbreak caused by the inmates, and also we have cooking equipment, the heating equipment. For example, the Switzerland or the country with colder weather, they have a heater inside the prison. Then we also see the electrical distribution is one of the cause of fire as well. Lighting equipments, and also playing with the heat source like smoking material and torch, burner, soldering iron, and etc. We see that in this number of fatalities from starting from year 2001 to 2012, these are the fatality caused by the deadliest fire in correctional facilities and detention center. Of course, there are a lot of deadly case. If more than 361 happened in the Honduras prison. So fire in cell spread rapidly, and they will also filled with toxic gas, reaching toxic level like this. These are the toxic level for carbon monoxide up to 1.5 ppm, or CO2, carbon monoxide and carbon dioxide concentration up to 5%, and also the level of oxygen will deplete and it will drop down to 14%. These are the dangerous threshold for this toxic gas concentration. That is the reason why we need the fastest way of detection. Of course, according to the NFPA 101, 120 seconds is the maximum time for the facility staff allowed to locate the fire and arrange assistance. So with better and faster response of the fire detector, we can gain more time to respond to the fire and plan all the evacuation plan. So experiments show that during the critical condition, uh, it's always reached before the cell temperature reach 80 degrees Celsius for releasing the sprinkler. So we will want to share some of the challenges inside the correctional facility. So of course, statistically, one of the leading cause of fire in correctional facilities is arson. So the conventional spot type detector are a constant problem to the facility operator due to the vandalism, okay, causing either frequent false alarm or frequent maintenance or replacement of this detector. So on the right, you see this detector is being covered with a plastic bag. So any smoke happen around this area will not be detected, and there will be no report of fire in the control room. So we need the use of variety of perforated steel cover to protect this detector. So this detector performance will become highly questionable because of the introduction of this steel cover. It will slow the smoke traveling back to this detector. So this cover also impede the smoke movement into the detector sensing chamber. Next, we look at the challenges in the environmental condition within the facility, such as the dust built up over time due to the mixture of the dust, cigarette smoke, or any humidity. With area with high humidity, the dust might be sticky, so it proved to be a problem for conventional detector. And of course, we need a early fire detection system that is highly sensitive yet reliable. Then, of course, the detector is able to give out a alarm in stages so that we are able to respond progressively to counter the problem of multiple layers of security barrier inside the area. We are not able to allow the mass evacuation like general application. We need to have a sequential uh, evacuation plan to allow all the inmates to run to a safe area. We look at the design and planning for a typical correctional facility. The gray area is outside is the overall high wall inside the facility. Okay, we usually have the general prison population. Then we have the medical center for all the inmates' health and safety. Then of course we have the re-entry preparation, the area where the newcomer are being prepared for their stay in this facility. Then we have a special maximum security room, and then a dedicated area for the women's prison, and also those administrative, recreation, classroom, etc., all in the middle. So area like this canteen or the food dispensing area, we are able to see Usually they are large common area for them to move around, and also having their uh, well-deserved lunch and dinner. So we are looking at the ceiling level of this area. We are able to provide the smoke detection with secondary smoke ASD. Okay, as you can see on the picture in the right, the ASD unit itself is located in the safe area within the administrative area. Then the pipe will extend into this large area, the protected area, at the ceiling level. So they are all hidden within the ceiling, the false ceiling of this common area. So there will be no uh, access to the ASD unit by these inmates, and we reduce all the possibility of vandalism in this area. Now we look at the access corridor to the general prison uh, inmates area. So on the picture, you see that we have two floor of room for the cell block. And due to the high ceiling of this area, we might need to install the pipe, the sampling point and the pipe of ASD system at the corridor and also at the top of the ceiling. So this area will require two layer of detection to comply to the safety code. Of course, the ASD unit itself will be placed near the control room or the administrative area or safe area. Now we look at the most important area for the coverage inside the cell blocks. So in the cell block, this is one of the example. We have the area for them to sleep, the table for study, and then we have the toiletry area. So to cover these rooms, we need the ASD pipe that run through each and every room, and they are being covered with a few points of point sampling point. So in the picture, you are able to see the sampling point is made of a special type of connection. Okay, I will explain this further in detail in the next few slides. Okay, so now we have all the ASD piping network and sampling point being designed. Of course, we need to determine the sensitivity class recommendation. So for general design, we usually refer to the very early warning or early warning, or this is in accordance to NFPA. Okay, and we are able to refer to EN standard for Class A and Class B as well, if you are looking for European market. So in this table, you will clearly see the sensitivity requirement for each and every classes. So for the NFPA, we have the very early warning. You require the transport time should be less than 60 seconds. And also the point coverage, each sampling point is covering more than only up to 18.6 meters square or 2,000 square feet. Then for early warning, the EWFD, each sampling point is covering up to maximum 37.2 meters square. Okay, so we need to take this into consideration during the design of number of sampling point within the area and also inside the cell block. So for the sampling points placement, it is usually at the ceiling level with or without the metal mesh cover. So this metal mesh cover is usually to protect the sampling point from vandalism. We also have the detector unit must be placed in the space outside of the restricted area. And a blind cap Outside serve as a commissioning or maintenance test point. So you have the ASD unit, then the sampling point network. Then at the end, outside of the protected area, we need to have a blind cat for maintenance purposes. And one of the solution for the pipe network, if we are able to put this pipe within the concrete layer. So to prevent the pipe itself from being damaged also. And of course, during this kind, when you design for this kind of design, you must allow for the different expansion coefficient of the concrete and also the ABS or PVC pipes. Because when two-layer detection is required for compliance of high ceiling area, vertical pipe with sampling point can be considered. Okay, this is for high level ceiling. And the sampling point can be pointing downward and also upward. It depends on the orientation of the building and also the ceiling slab. Okay, seeing plenty of words is very difficult, so I'll try to show some of the photo here. For example, for all these sampling point, we have a tamper-proof design kind of a sampling point. So this is to prevent the vandalism caused by the inmates. So, and also the ASD itself is installed in a secure area. So we can see this ASD point is especially designed near the top of the room so that they are not reachable by the inmates. And we have our standard point here shown. They are only seeing 2 points of a sampling point located near the door, and they are situated high up, so they're not easily accessible. Or we can have a vendor-proof type flush with the concrete. I'll show you in the next picture. Another way of a possible solution for installing this PVC or ABS pipe inside each and every room, we have the pipe extended into the room with sampling point, okay, already installed, and then they are being covered with metal mesh here. Okay, so what are the difference between these metal cover compared to the conventional detectors and also ASD? For conventional detectors, you are waiting, those detectors are sitting there at a fixed location, and they are waiting for the smoke to travel to the detector and report a fire. And then for ASD system, we have the pipe installed inside the metal mesh as well, but they are constantly, their air being drawn from the sampling point back to the ASD for sampling. It is an active system instead of passive type. And of course, for conventional detector, they are usually less sensitive. So for ASD system, we are able to set the sensitivity from class B to class A and above, so that we can have the multiple level of fire alarms, like pre-alarm 1, 2, or 3, to gain extra time for the staggered or sequential procedure for evacuation if there is a fire. So we also see that we have invisible intake opening. Okay, so all this area, the air is being drawn for the circulation of air inside the room. We can place the ASD pipe within the area to monitor the smoke particle in the room as well. So generally, when you see there are multiple rooms for the cell, you have the ASD unit installed outside and the pipe being extended into the area and then goes into each and every cell. So we are not able to determine whether is it a cell 2 or cell 3 is there are fire happen inside the area. If you need such accuracy and also pinpoint location of this fire, we have a solution of using the REK, okay, to determine which cell is in trouble. So if you can see here, the REK is located at the head of the branch. So if there is smoke from cell 1, they will reach to this REK first, then before they are being transported back to ASD for smoke analysis. So if cell 1 is in trouble, the REK for cell 1 will light up, okay, will give an indication, and then the smoke continue to travel back to ASD and will give a relatively the alarm level as well. So we are able to pinpoint that this cell 1 is in trouble or there is fire happening. Okay, of course, all our product here are approved to the international prestigious standard like the BDS, UAFM. For Malaysia, we have Bomba Malaysia. For China, we also have the CCC, and Korea market, we have the KFI. So we comply to all the major standards available, product standard, and we are the one of the very best product of ASD system in the world. So all these pictures and references here are referring to the correctional facility in Grashof, Kriens of Switzerland. Of course, there are more than 30 other prison and detention center, and this is one of the reference that we did for the ASD system in prison or the correctional facility. Okay, so we have a lot of case study, or we call it a vertical application management design. You are able to scan this QR code and download the guideline here for your own study if you require them. Or after this presentation, I mean Chan here, he has all the list of attendance through the email. We are able to send this to you if you require all these document here. Okay, so is there any queries from the floor here? I mean,
Yeah. Do you have any questions?
I'm done here. Yeah.
Sure. Thank you, Cafe. Thank you. So to all participants, do you have any questions? You're muted also. Yes.
So you can unmute your mic.
If you have any questions, you can unmute yourself and put forward your questions.
Yes. Not only in Switzerland, because European country, of course, due to the human rights law, there are, of course, more requirement of this fire detection and also human life safety priority for this area. Now we are also seeing plenty of inquiry for fire alarm detection in prison, such as in the Middle East country, UAE, Saudi Arabia, and etc. And then, of course, for Asia, we at this moment we do not have any installation yet, but we hope someday we have a better fire alarm detection system to also keep our inmate safe. So, is there any question regarding the design for ASD or any fire alarm detection system in correctional facilities?
Hello, good morning.
Hi.
Hi, good
Yeah.
morning.
Okay, this is some of extinguishing. I have one
Mhm.
very particular question regarding with the FDAS panel. Uh,
Okay.
we are having right now we are having a hard time competing with UL listed panel. when the Newton will produce a UL certified FDAS panel?
Oh, the fire alarm panels. What you mean is the fire alarm control panel?
Yes, the FACP panel. Like
Oh,
the
okay. To be honest, from what I've seen and notified by our management, we are not going with UL or FM for the fire alarm control panel system, unfortunately.
Yep.
Yeah,
Purely business direction or business decision
yeah,
from
yeah.
the high ups.
oh,
So yeah, so unfortunately we don't
that's
have that
sad.
available for you.
Because here in the
Yes,
Philippines, all consultants
understand.
all required UL listed, so we are limited with the ASD products and heat detector. Anyway, thanks for the answer. Thank you.
No problem. This is same for Thailand market and also Malaysia market. We have some requirement of the UL for fire alarm panels. Okay,
By the way,
thank you for
Cafe,
your question. Yeah.
yeah, good. For regarding the one slide you mentioned about the tamper-proof sampling point, is this something that we have as a standard in Securiton? Is a engineered solution, engineered component? Can you share
Okay.
with us about a bit more about that?
Maybe I move back to that particular slide. This vendor proof is not part of our product range. Okay, it is actually the product carried by our own business partner from inside Fire. So they are having this component to integrate with our fire alarm system for this special application in prison.
Okay. Thank
Yeah.
you.
All right. Okay. So is there
Any more
any
other
other
questions?
question?
If not, I also ask one last question.
Yeah.
So I think from this webinar, it's very apparent, very clear that aspirating smoke detector or ASD is the prominent form of detection we are talking about here. But
Yes.
are there any other type of detection technology or apparatus that can be also considered or useful for this application
Of
besides
course.
ASD?
Yeah, of course. So for this webinar, we can see that the ASD is the main focus here. But if you have area like outdoor and there is no roof above, and you might have, let's say, a workshop. Okay, maybe there are correctional facility that having a workshop, for example, doing all their craftsmanship work or the woodworking study. We are able to do a lot of study inside this area as well if you require them. So those workshop area usually they might have all the machinery or like milling machine. Okay, we that do not have a roof on top of them, then maybe we are able to use a linear heat detector. Okay, for example, our ADW or lease cable. And beside this workshop area, when you have a very long consecutive corridor, okay, instead of ASD, we are also able to deploy the beam detector. Okay, we have our industrial grade ILIA beam detector uh, with a maximum coverage up to 200 meter. Okay, so when the corridor exceeds 100 meter in length, one unit of ILIA beam detector is able to cover from the beginning until the end of the corridor. So of course, it will depends on the width of the corridor. So we need to check with the standard of installation, like maximum distance between the transmitter and receiver is up to 200 meter, but the next set of beam detector is maximum up to 50 meter if you do it according to BS standard. So it depends on the area and also the application. We are not only confined to one type of detection like ASD. We have, of course, linear heat detection and also beam detection.
Okay, thank you, Cafe.
Okay.
Yep. Would you kindly go to the last slide? So that's about the that concludes our webinar this morning. Of course, if you have any questions that comes to your mind after this that you don't have right now, feel free to drop us an email. Maybe I'll just quickly introduce the team members here. So in the ASEAN so-called team in this region, Southeast Asia, we have if you look at the names here, like if you look at Niran is our sales and marketing manager in Thailand, responsible for the Thai market. And then below, there's Yong, who just recently joined us. He's based in Saigon in Vietnam. So he's responsible for the Vietnamese market. So apart from them two, the rest of us, myself, Chan, Theo, Daniel, Kai Bin, Cafe, and Jess, who also just recently joined us. Jess, our new design engineer, based in KL office as well. So feel free to drop us any emails or any questions you have regarding this application or any other application that you might have regarding products as well. And of course, below that is our office address in Selangor, Malaysia. So that's where we have our regional design and support center. So that's where Cafe is located. That's where we receive all these design requests coming in, and then we churn out all these drawings and proposals to our business partners. And we also have a demonstration room. We can accommodate you if you'd like to visit us in the future to understand more about Secreton solutions. You are always welcome to visit us in Malaysia. So with that, I think we shall conclude today's webinar. Please tune in for our next webinar that we will be holding, I think, in month of April. So we will let you know the topic soon. So please join us again for our Secreton webinar. Thank you very much for your time today. Thank you.
Thank you, everybody.
Bye-bye.
Bye. Have you stopped recording?
Oh, thank you for reminding.
Okay.